Hello, everyone, and welcome. I'm Joanne Emery. I'm the Event Director at Infinetics Research, which is now part of IHS. And I do want to thank everyone for joining us on the webinar today. The focus of our discussion is going to be on virtualization, and more specifically, we're going to talk about virtualization for the broadband edge. As you can see from this title slide, we're going to be talking about the fast way to launch new broadband services with virtual networking. And we're joined on this webinar by our partner, Active Broadband Networks. Before we start this webinar, I'm going to just go over some of the functionality on your console and also talk about how you can participate with us today. So first of all, the console that you see can be customized for your own preference. If you want to maximize the slide view, which is the main part of the presentation, you can just click on the top right-hand corner of that window. You can also move or resize any of the windows just by clicking on the bottom right corner and dragging. And you can open other windows we've made available for you which have more features. You're going to see a number of buttons across the bottom of the console, and you can access all of these during the session today. One area I want to call out is the resource list. That's the button that looks like a file folder. Usually it's the fourth over from left on your screen. So this is where you can access the downloadable version of the slide deck from the session today. And in addition to our slides from the session, we also have a white paper from Active Broadband that's titled Virtualizing the Broadband Edge. And that's available for you to download. So please go to that resource list, and you can download all the materials right from the webinar today. Now, some ways you can participate. You're going to be seeing, number one, you're going to be seeing a Twitter feed running on your console. So you can post and view tweets right from the webinar, and we'll be using a hashtag NFV Broadband Edge today. We're also going to be having a poll on the webinar, so watch for that. We want to get your input on your company's experiences with virtualization. So please do participate there. We'd love to see your answers there. And lastly, I want to mention our Q&A period. We are going to be taking questions live directly following the presentation, so I do encourage you to submit questions as you think of them. You can use the Q&A box you should see on the left side of your screen. If you don't see that box, just click on the Q&A widget on the bottom of the console. Any questions we can't get to on the webinar today, we're going to follow up with you directly after the session. So now, with those details covered, we're going to get started. I'm going to turn the controls over to Michael Howard. And first of all, I'll say many of you probably know Michael. If you don't, he is co-founder, principal analyst at Infinetics Research, now part of IHS. And Michael has been driving the SDN and NFV research coverage areas. So Michael, over to you.
Thanks, Joanne, and welcome all from wherever you are. So I've been involved with SDN and NFV now for several years. It's been my prime focus area, and so it's fascinating to watch how progress has been made, even can be measured every 6 months. And I'm happy today to have Active Broadband Networks as our partner for this webinar, who's another one of the proof points that you can use virtualization, SDN, NFV, these new technologies in the broadband network. So I'm happy to introduce Adam Dunson, who is the co-founder of Active Broadband Networks. Welcome, Adam.
Thanks, Michael. We're pleased to be working with you. You're clearly a recognized expert in the area of network function virtualization. So, thanks very much. This is great. By way of background, in late 2012, Chris and I, Chris is the other founder of the company, thought we could take our service management software, which was largely OSS software, and the skills we'd had from previously in building routers, to build a new and different and ultimately virtualized platform for the edge of the broadband network. And I would say that virtualization has come to the edge of the network. Would you agree with me, Michael?
Sure would. So that's, in fact, the edge is where almost every operator, whether it's broadband, mobile, They're using NFV, the virtualization, for customer services. You can look at it as managed services is another way of looking at what is being delivered with virtualization, only with a lot more economy and operational efficiency than using the old methods. So let me just get started here. We're going to I'll open up with a little bit about market trends, and then we're going to move on to drivers and some more interesting topics. So first to say, there's no doubt that operators will deploy SDN and NFV. We did a big survey this past year where the carriers that control 51% of the world's CapEx were part of the study. Whoops, went too fast here. And what we found was, I'm having trouble clicking here, sorry guys. Here we go. Okay. And so what we found was 97% said they will deploy SDN at some point, 93% they will deploy NFV at some point, and that few percent left at the top, no one said no. But a few people said we don't know yet, and so there's just no doubt. And now to look at the specific drivers for NFV and the drivers for SDN, it's about revenue. And so if we look on NFV side, the top drivers are scaling services up or down quickly and use software for quick revenue. On the SDN side, it's cloud services for customer and access for business, exactly what we're talking about here in broadband networks. And then secondarily, so remember, most people are talking about CapEx reduction or operational efficiency, and yes, those are drivers. However, what the carriers say is that it's about revenue and revenue agility. In fact, that's what we're going to talk about today here. Adam has some good points to bring. So then the secondary driver for NFV is use commercial servers rather than network equipment. And of course, the definition of NFV is where you virtualize a network function that has been running in special purpose hardware, especially built hardware, like a firewall, will be moved to software-only version that runs on servers. And then the third driver is operational efficiency. And absolutely the whole point of SDN and NFV, the whole drive by carriers is to get to a much more automated network, a programmable automated network. And that means, of course, operational efficiency that achieves it. And so I'd like to just point out, besides NFV directly, there's another approach where the service providers plan to move services off of physical routers, and we're going to talk some about this today. So the PE router today, or the provider edge router, or some people it's a IP edge router, placed at the edge of the network, delivering services like BRAS, the broadband access, subscriber management, or carrier-grade NAT and firewalls and content delivery networks and IPVPN. So all of those services are delivered today on a physical PE router. And of course, the basic founding principle of a router is that it's the data plane packet mover. And so the carriers have different plans for routers in the future, and that is, the big plan is to keep that PE router, but sometimes virtualize it as well, depending how far out in the net, close to the customers in the network it's placed. But basically to change the role so that the PE router is just more fundamentally used for a data plane packet mover. And we found, and I'll show you in a minute, the actual statistics, but service providers are planning to move these services like BRAS, carrier-grade NAT, firewall, etc., onto servers. So they're running as virtualized network functions on servers. And in fact, in some cases, the virtual PE, the PE router can be a virtual PE router itself running on a server. So interesting, we have these trends, essentially overlapping trends here of service providers are planning to move functions, a lot of different kinds of functions on the servers. and specifically for the edge router moving services off. And here's the statistics from a major study that we did last year of router departments at carriers around the world. So here's the actual list of functions that they plan to move off of physical routers onto NFV servers. And the list, if you look at the percentages out there, over time, 75% of the carriers are planning to move firewall off onto servers. And if you just go down the list all the way down closer to the bottom, the IDS, IPS, almost 2/3 are moving that off. So a lot of operators, this is pretty much a majority, this is a unqualified measure of a trend. This is going to happen. There's no two ways about it. So with that, we're going to have our audience poll question right now before we move to the next section. So I'd like to have you all select your top 3. So the question is, what's the biggest challenge to overcome in deploying NFV software for you and in your broadband network? So select the top 3. So use your clicker and choose 3 different of these options. Is it NFV platform performance that is the biggest challenge, or is it the operations and management functionality of that platform that represents a challenge to you? Or is it the lack of NFV knowledge on your technical staff? Or is it you now have to sell software-based services to your customer? I know other operators around the world are seeing this as a barrier. What about deploying software network functions in an NFV server environment, bringing the IT knowledge necessary to the network folks, or designing a new network topology that includes that server environment? So how do you measure, how do you combine the network and the traffic flows and make that operate in a server environment? The network connected to the server environment back to the network. So there's a number of challenges here. So name your top 3. And Adam, do you have any observation about this question?
I think about these questions, what it reminds me of is the stages we had in compute virtualization where, initially people went and they took servers that they were running in the same functions and, just virtualized them. And we went through that whole phase that was called, the virtualization phase. And then we had the cloud phase after that where the functions were reorganized and perhaps didn't look exactly the same as they did when they ran on bare metal. And we're heading into that phase in network virtualization now. Instead of grabbing the thing that we used to call something in the hardware world and running it on a server, people are now looking at how do you reorganize functionality to really achieve the best possible outcome.
Good point. It's a good observation about this question. So our audience out there, go ahead now and submit. We're going to close the polling here in just a second. Some people are still answering, but go ahead and answer now. And I'll give you a few more seconds, and then we're about to close it. So I think we're about there. So let's go ahead and push this. We'll go ahead and push. I'm trying to push it. Joanne, how do I push this?
Drum roll, please.
Drum roll. There we go. Here it goes. Okay, thank you. Okay, so here we have, the top 3, when we ask that way, the top one turns out lack of NFV knowledge among our technology staff. So sometimes the way this is true for carriers around the world, we found out, and that you choose a partner that knows what they're doing is one way to overcome that. And then designing a new network topology to include the NFV server environment. Right, this is a very common
Don't know if we lost Michael there. Sounds like his audio might have gone dead. Adam, do you have any comments on the poll here?
We see, similar things. This is, it's interesting spread across the list of questions there. I think going back to the level of analysis that needs to be done to deploy network function virtualization goes all the way back down to, inspecting the topology that the network is created on, and therefore it's a significant and daunting task. That said, the benefits of heading down this path can be very significant.
Yeah, I'm seeing the selling of soft. Oh, there's Michael back. There you go, Michael.
Yeah, sorry, I didn't mute my, I was talking, but it didn't work. Okay, so my observations were that, around the world there's a lot of carriers and they have these same problems and they've overcome these issues. And so the lack of NFV knowledge on their technical staff, everybody, it's a new world. People have to learn. And it's good to choose a partner that knows what they're doing. And in this case, we're talking about ABN, and they know what they're doing here, and so they're a good partner to choose to help you bring your staff up to speed. And Adam commented about designing new network topology. And so carriers around the world have the same problem. It's all brand new. It's all new stuff. So choosing a good partner to work with is a good start, but basically everybody's in learning mode. You have to learn. It's a barrier, but it's one that everybody has to overcome. Okay, so let's move on and get started with the rest of the show here. So next we're going to talk about drivers for change, and Adam, let you take this part.
Thanks, Michael. When you take it back up to a higher level, the issues aren't especially new. Internet growth, service cost deployment, new revenue, and then, of course, a new class of competitor that today is not really that new. Over-the-top providers are not really a new phenomenon. So the challenges are not really, surprising. And, of course, the solutions to those problems are not that surprising either. They're fairly pragmatic things, and they're things that we've always done, which is try to drive costs out of deployment and, be able to react to competitors and find new ways to do business. But the devil is in the details around how you actually do this. So let's actually jump to one of the key topics, which enables one of the key benefits of this, which is cost. So going back and when we look at what we've done over the last 15 or 20 years in specialist telecommunications equipment and routers and broadband network gateways, or PE routers in particular, is they've been on a particular hardware cycle that I'll call a network hardware platform development cycle. And it kind of went like this. It kind of went with starting with an ASIC development where, it'd be a significantly faster new feature, rich ASIC development. And, they take 9 or 12 months, and you don't get a lot of change out of $10 or $15 million when you do ASIC developments, followed by, a hardware board design component, which 6 months to 9 months, depending on, the complexity of what you're building. Then butted into this and slightly overlaid would be a bunch of software development. And then because you'd really made significant changes, changed the underlying processor infrastructure associated with it, you had a fairly significant platform cycle. And so the realization of this is that 3 or 4 year cycle that we saw generational hardware-based routing equipment come out. It served us very well. What vendors did, they did a great job of attempting to drive the cost out of that type of methodology, making that methodology work as quickly as possible. And it served us very well. But it had significant sunk costs associated with that because, of course, not only does it cost a lot of money to do the development, cost a lot of people, from the day that you start investing in that development, you've got a 3 or 4 year carry cost before you see revenue associated with that. And that all changed when general purpose processors provided I/O optimization in the high performance server marketplace. And so let's talk about that for a second. This is the fundamental change in network function virtualization. So you really have two tracks going on at once. First is you have the hardware development track, and Intel's the leading proponent of that development track. And of course, they're building general purpose, high performance computing parts. And they're building those parts and amortizing them over the whole high performance computing industry. It's a far greater number of parts than a forwarding ASIC in a traditional, telecommunications router vendor. And so they're operating down the path, and they generally bring out new parts every 6 to 12 months, and that cycle continues, and the people who build servers follow it down the path as well, and of course, they amortize their business over a much larger group. Companies like Active Broadband go and write software to do that, to provide this functionality, and because we're on this continuous upgrade path, we're in about a 6-month software cycle. And so we're able to add new features in line with new performance. But most importantly, from a cost perspective, we don't have this carrying cost associated with developing a fully integrated hardware platform. And the cost difference, this is the underlying cost difference or economic difference that drives a very different set of economics associated with this platform, really unlocked by the ability to use tools to do I/O optimization in servers. So let's focus this now.
Yeah.
Sorry.
Okay, cool. Right, so there's...
So let's focus this...
Can you hear me?
I can, Michael. I think, we're in different parts of the world, which is making this a little bit difficult.
Well, go ahead.
Okay, I'll continue along instead of leaving dead air, as they say in the radio business. So let's move on to, the specifics of the edge of the network. When you look at the traditional, edge network environment, there are really, 3 key components in it. The OSS component, once a simple radius server, has evolved over time into a complex of many different parts. And then it talks to this thing called a BNG or a provider edge router, and inside that are 2 key functions. One is edge programming, and these edge programming functions include a specific set of quality of service and access control functionality that is largely different from routing, and then routing, which is a complex and discrete function in its own right. And a way to virtualize this is to reorganize the OSS functions into a controller, and then take the edge functions, put them at the edge of the network, and then virtualize the router as well, and build a somewhat different topology of connectivity and functionality inside the cloud infrastructure. And so when you do this, if you go and move the edge into the cloud, what you can now do is change the way that you architect the cloud interconnect fabric. In fact, instead of looking at the network as one cloud, and it's funny that, we networking guys have used cloud icons to obscure complexity, and now the computing guys use cloud icons to obscure complexity as well. Instead of these being 2 separate things, what we do is we kind of turn them on their side and lay them over the top of each other. So the network provides an underlying fabric for the cloud infrastructure. But because access is now in the cloud, instead of steering the customer's traffic all the way through the network infrastructure to try and get to the cloud where network function virtualization is, you just connect them directly up to the cloud. And now the customer service is directly connected and tethered to the cloud, and you can put services up behind that. With that happening and the customer now connected to the cloud, the next challenge is, how do I achieve network function virtualization? So let me digress for a little bit. When I listened early on to the conversations around network function virtualization, there was one thing that stuck in my head and that I really struggled to understand, which was, if I'm going to take this particular use case, the virtual or the managed service enterprise router, and I'm going to pick that up, take it out of the customer premise, and then lift it and put it over inside the cloud virtualized, it struck me that wouldn't I have to transit a router to make that happen? And didn't I put a router in the premise to connect to another router, which was the edge access device? So how would I do this? I mean, as soon as I move the router to the other side, I'm just tethered to the provider edge router, and if I could do that, then why do I have the router to start with? And so when we looked at this problem, we thought if we could go and separate the edge programming functionality, which is a task in its own right, which is driven by customer service entitlements and authentication, then what we could do is we could pick up that CPE router and move it into the cloud. And in fact, by separating out inside the virtualized BNG functionality, the edge functionality, and routing that's shared to connect to the network, we create a space in the cloud that is logically co-located with the customer premise. And so now we can go and grab this enterprise virtual router, put it inside the cloud, and use edge programming to steer traffic to that particular instance. And of course, one instance, as I said, is a virtualized CPE router, but there can be other things here connected as well. So this gives us a fundamentally different way of being able to move these functions very simply into the network. And vCPE is one of them, but there's lots of other things in both enterprise and residential that can be moved into this environment. Of course, one of the benefits that service providers have over plain cloud providers is they have a significant network infrastructure that provides them with significant reach throughout their geography. And that's a benefit that, a generalized cloud provider does not have. So they're both connected to customers and they have reach throughout their geography. And so how do you lay the cloud over the top of that reach? Well, the way that you do it now that we've connected the customer into the cloud is put the cloud over the top of the backbone network and use the same technologies that are used to create multi-tenancy inside the cloud, and a popular choice is VXLAN, to go and create an overlay fabric that connects your cloud network together. So now we can go and take a customer that we've connected up, perhaps they were sitting on a DSL or a PON service, bring them into the cloud, have them in their own isolated environment. That environment might consist of their enterprise router. It may consist of backup services and other things associated with that. And that network, because of the benefit of the service provider cloud, can spread across that geography using that multi-tenancy technology. And where you want to create connectivity to the internet, you take your virtual router, connect it down to the backbone network beneath it, and you have access to the rest of the network and the ability to go out and talk to the internet. So a very simple way of being able to add virtual routers, many virtual routers to that infrastructure. So the challenges that we've had to overcome and that need to be overcome to achieve this are both performance, and some of the opportunities are workload. Performance is usually the topic that most people want to ask and drill into when we discuss the platforms that we've built. And as we've talked about, and as is commonplace around the market, Intel's done a great job talking about using Xeon E5 family processors as packet forwarding engines, and we've exactly done that. We have used Intel's DPDK toolkit to provide the level of I/O optimization necessary to get the performance necessary at the service provider edge of the network. And in doing so, we had to do a bunch of kind of pretty interesting things. And one of the most important things that we had to do was implement a complex, rich queuing structure in software, something that has never been done before, that allows customer services to be instantiated in queues at the edge of the network in the same way that they are done with hardware products. But of course, the other advantage is scaling the same problem in a VNF environment than it is in a hardware-based environment on the 4-year cycle. Of course, each year, as we said, we get new processor technology, but beyond that, we get the ability with virtualization to use the compute horsepower in these locations in a variety of different ways, be it building a very, very large edge access function, or building lots and lots and lots of very small edge access functions, one for each particular type of service, or a mix of both that can provide you with a different way of delivering workloads and an amount of flexibility in the way that you introduce new services and bring them to market.
So fascinating. That was a good example or a good set of knowledge for all of us for how to use NFV for broadband services and some of the particulars that you, Adam, had to go through and your innovation of the buffering, software buffering in your software as opposed to in the hardware. So pretty fascinating. So that's a technology. Now, how are service providers applying this in their network? That's the next topic for you, Adam.
So let me do three, kind of simple, kind of use case examples, Michael, as we describe how this technology can be used. The first example is really, recreating, but creating it in software, something very similar to the edge of the broadband network for perhaps residential services, where access connects into the virtual edge. The virtual edge controller, controls that edge, and behind that we put a vRouter. And the vRouter is doing the role that is, very similar to that of the bolted together functions that exist in the hardware-based, less flexible hardware-based platforms. And so the controller and the forwarding engine together provide access functionality, and then the forwarding engine provides connectivity to virtual services, either within that same hardware footprint inside the same server or across servers within the same complex or, other complexes as well, using multi-tenancy techniques at a very low scale using things like VLANs, but at a higher scale using things like VXLANs. And then the vRouter operates as a router does. It's programmed by, routing protocols and routing tables. And let me say and be clear about this, we're not suggesting that routing is not the best way to connect networks to networks. It absolutely is the best way to connect networks to networks. Where things have got complicated over the last, 7 or 8 or perhaps 10 years is when we've included connecting customers to applications and all of the service components necessary to do that and combined them in with routing. We've created very, very complex platforms, and this is a way to separate out that platform and make it a lot simpler.
As I was showing in my diagram of the edge router, the PE router, carriers are now planning to go back to that original simple way of a PE router. It's the packet mover, not the service delivery vehicle.
Yeah, exactly. I mean, it's worth remembering that as we go back in time to the early days of providing internet service and the build-out phase, that we connected these things called BRASs straight up behind DSLAMs, right up directly behind the back of the access device. But network platform economics has resulted in those devices that are terminating customer sessions to be pushed way back in the network, and for good reason. The reason is that as vendors did the right thing by their customers, taking cost out of components in the network, they used increases in performance to reduce the relative cost per customer. And at a certain point, it got to a threshold where you could achieve those savings, but you couldn't connect that, but the device was too big to sit directly behind the network termination component. So it got pushed back into the network, and a bunch of cheaper devices, switching got put in front of it. And the topology actually, followed down the path of the raw materials available in building the network. And that's why I was pleased to see in the poll questions, Michael, that people recognize that rethinking topology is a key challenge associated with virtual network functions.
Yep, it's a big deal.
So perhaps the next simple example is, one of the functions that operators use to, improve video service delivery, phone software updates, a variety of different things is caching. And as we all know, caching is most effective as close as it can be to the edge of the network. And as the edge of the network, or the packet termination edge of the network, has moved further and further back, caching has become less effective as it gets shoved further and further back in the network. In this case, with this type of model, you can actually put caching between the customer access and entitlement and the first hop router to put it as close as possible to the customer and achieve the maximum effect, and then use virtual network functions and the ability to change workloads to deal with the changing environment of the applications that you're trying to cache or the service you're trying to cache, like, a massive upgrade to a particular brand of smartphone. But now to get to the point that we started talking about, which is, how do you do enterprise virtual routers or virtual CPEs? And so it should follow along as we've kind of built up this. I'm connecting my customers into a forwarding engine that then has the ability to compartmentalize and steer traffic into other places. A terminology that's often used for this is service chaining. That as part of the customer entitlement, we can now go and say, turn the customer up, give them some set of queuing, some other functions associated with that, perhaps some ACLs and general packet matching functionality, and then steer that traffic off to a specific vRouter that is inside the cloud complex, dimensioned for the performance of their enterprise routing function. And that's an important point because, of course, as we talk about bandwidth, we dimension and sell services at much higher speeds than often routers are used at. And it's because the speeds that we sell, we largely sell speed for latency and to some degree for performance, for capacity perspective, from a capacity perspective, but it's largely for latency. So you connect the customer up in a gigabit speed connection, but their actual usage of that connection is much lower, and therefore the router associated with that, needs to have the appropriate performance to be able to be small enough for the real use of the customer, or alternatively large enough for very high performance customers. And again, this I/O optimized environment that we have from Intel allows us to do exactly that, to run very small instances without I/O optimization like DPDK, or provide very high performance instances using technology like DPDK.
Yeah, so good points and good examples of how carriers are using and can use the NFV for delivering new services and delivering them quickly. Let me say that we're getting close to the end now, and be sure and submit your questions. We have quite a few questions in the door already. Be sure and ask your questions as we go along. We're going to take them fairly soon, but just wanted to remind you to go ahead and submit them now. And so back to Adam, I think we can guess a little bit, but what is Active Broadband Network's approach here?
Thanks, Michael. I'll do this very quickly. The two party political statements here. So our platform consists of two components: a controller that we call the Active Resource Controller. It's virtualized, has no specific server platform requirements other than the usual things, compute, storage, and network access for control plane. And what we've refactored into this platform broadband edge orchestration, the process of activation, and once they're active, once customers are active, we also brought in the ability to do analytics on customers' individual service usage from an IP flow perspective, and then apply policy actions and automated quality of experience associated with the controller. The controller talks to an OpenFlow-based intelligent forwarding engine, and our forwarding engine we call the Active Programmable Gateway. Again, it's all software. It can be virtualized or run on bare metal, but predominantly virtualized, and it provides the edge admission control forwarding and quality of service that a traditional line card would do in the kind of hardware-based environment that we came from. And again, it's all software, but in this case, of course, we do depend on Intel E5 family, 2600 family processors, so we can be I/O optimized. Although, they're a pretty general purpose processor these days. We had to do some, very interesting things. Sorry.
Yeah, let me just comment that let me just back up the slide one and say that in our work with carriers around the world, we see that the big goal for SDN and NFV is automation of the network. And in order to automate, I just wanted to point out to folks that, yeah, everybody knows you need orchestration and activation, get the services in place. But in order to automate, you have to have the programmability, but you need to be doing analytics, and you need to feed that back into policy in order to make quality of experience happen. So I wanted to just point out that ABN has these elements. It's not just the basic platform, but the rest of the elements of analytics policy to ensure quality of experience that carriers are wanting in their SDN and NFV platforms in order to achieve automation. You don't get it immediately, but these are elements that have to be built in. So I'll let you proceed. Sorry.
Thanks, Michael. So let me talk about very quickly about three specific things that we did. So one was that we needed to implement large structures of complex queuing in software, something that is done in a very different way in hardware. And so we had to, invent some technology to be able to go and make that occur. I'll give a very simple example of kind of what happens. In a hardware-based forwarding engine, you have all these, it's structured specifically for queuing, and what you do is you have the ability of something called parallel execution, where you have a single instruction that you call to ask all the queues if they have something to send. You don't have that structure in a software-based forwarding engine in this general-purpose processor environment. So if you use the same model, what you end up with is a quality of service queuer that's spending its whole life consuming clock cycles trying to figure out if it's got something to send. We used some specific technology called future time scheduling to go and address that problem so we could build large complex structures of queuing. The second thing that we had to do was, overcome perhaps the perceived scaling issues of OpenFlow. For the wrong reasons, OpenFlow's got a bad rap on scalability, and it's no better or worse than any other internal, proprietary, or external control plane protocol between control processors and forwarding engines. And, Chris knows this. He's worked on a variety of different brands of large-scale routers. And so all we did was we did the same thing that you do with routing, and that is provide as much programming as you can with the OpenFlow construct to the forwarding engine to allow the forwarding engine, like a line card in a router, to make as many autonomous forwarding decisions as possible without having to ask the control processor what to do. And this allows us to scale the controller and scale the forwarding engine to the levels that we need to operate at the edge of the network. The second thing we did is we simplified and refactored the OSS environment. All those disparate parts, we thought about how we glue those together in a workflow chain that allows you to orchestrate, activate, monitor, and provide policy and QoE. And while we did that, we used web services technology such as HTTP REST interfaces and message queues, such that we made the programmability of the platform as accessible to programmers as possible. We don't use proprietary protocols. You don't have to go and figure out where to get a diameter stack from. We really tried to use protocols for our own purposes because it made it easier for us to hire developers, and it also makes it easy for our customers to get access to the platform and integrate it in whichever way they see fit. And then, of course, finally, by moving all of this into a virtualized environment, we make it a much more flexible environment that can much more easily be deployed.
Very good. So thank you, Adam. So I'm going to just wrap up here pretty quickly. So we've delivered the content. We're about to go to Q&A, but we've learned here today the fast way to launch new broadband services using NFV, using virtualization. At the start, I showed the data. Service providers around the world are planning to deploy SDN and NFV. There's no doubt about it. And NFV investments are driven by revenue, by service agility, and moving services off of routers to servers. All of that gives service agility. The fact that, as Adam pointed out, we're moving to a software platform, the rate of change of being able to develop and bring on new products is much, much faster in a software world than in the hardware world. And the NFV cloud environments provide high performance. They provide the ability to scale out and scale in to meet peak traffic, broadband traffic. Also, NFV can be used to simplify and to automate and speed up time to market for new broadband services. So I think we saw all of this in our webinar today. And before we go to Q&A, I'm going to ask Joanne to give us a word here.
All right. Thanks, Michael. And I know you are looking to organize the questions here, so I do want to remind the audience we're going to get to our Q&A period here, so please do send your questions. We've got quite a few coming in, and we can always handle a few more. One item I do want to mention is that for the audience, you're going to be seeing a survey pop up later on after the webinar, so please respond to that. We'd love to get your feedback here. Also, just a reminder, you can download the slides and the white paper about the topic today, the virtualization of the broadband edge, some really good material there. Make sure you go to the Resource Center. You can download all those materials from the session today. I know we've had a lot of information presented here, a great topic, some really timely information. And Michael, I hope, are you ready to tee up this first question? You and Adam, ready to tee this up? We can toss it back to you, Michael, if you're ready.
I'm ready.
Okay, keep those questions coming, everyone.
I'm ready. Can you hear me?
Yep, we got you now. Go ahead.
Okay. Okay, great. So the first one is a question about open source. So, Adam, is the orchestration based on open source project like OpenStack?
Yeah, so I think perhaps I'll ask a question and then come back to that. I mean, orchestration has become a buzzword like policy is. It means so many different things. I mean, how do you think about, orchestration? Then I can talk about how we think we fit in.
Well, this was a question from the audience, but orchestration is a word that's used in the industry in a lot of different ways because there's many different kinds of orchestration. In the NFV world, there's at least service orchestration and infrastructure orchestration. The infrastructure orchestration is a place where OpenStack can be used, and that infrastructure orchestration is to orchestrate the servers, the compute, the storage, and the networking, where the VNFs get executed.
Yeah, so I think, where we fit into the puzzle is we're undertaking the process of orchestrating edge services. And so we would, in an environment where we're deployed in a cloud, we would sit, and our platforms or our VNFs would sit underneath OpenStack control. And so, things like our controller platform would be spun up and largely stay up as, while services being delivered, can be added and removed, scaled and upgraded and moved around and, using normal cloud technology. And then we would expect that our APGs or our forwarding engines are brought up, kind of as necessary. So they're either brought up, to meet scale requirements, expanded to meet scale requirements. But we're sitting underneath the general cloud orchestration environment. And there's probably, another orchestrator. As we drill down this hierarchy of orchestration, there's probably going to be other orchestration elements associated with it. We use Open Daylight inside our platform. We make no secret of the key components inside it. And, we build our own source version of ODL from Helium. The difference between us and perhaps other people who provide, open daylight is that we don't provide a general purpose open daylight. We build it, support it with a minimum set of modules inside ODL, and then we go and build our forwarding engine abstraction, or the logic that goes and creates the open flow programming inside that OSGI environment that open daylight is. And so, there's no reason that a customer couldn't say, hey, I've decided to buy or use a general purpose open daylight environment. How do you interact with that? Notwithstanding the maturity level of open daylight, we would bring simply, our forwarding engine manager into that standard Helium environment. So I don't know if I answered the question or went, down a technical bit of a rat hole there.
No, you did answer the question. So very good. So let me ask you another one from our audience. Typically, the hierarchical edge QoS function of the virtual BNG is very complicated and up to 5 levels. And so has ABN simplified the model towards software implementation? What have you done about QoS?
Yeah, the implementation is a little bit different. And so I think if you go back to what's generally required is, a customer is instantiated in a pair of queues, one going to the provider and one coming away from the provider, at a minimum. So at least a pair, and then often within that pair or within those queues or those rate-shaped queues, there's some level of hierarchy required to go and deal with, ordering of traffic, delay, and transient congestion, which is occurring all the time. And so we're in a fairly flexible environment because we're in software. So today, we do hundreds of thousands of queues in software. We can have those queues applied, as simple as one up, one down, each with 8 classes behind it with red and WFQ, or multiple queues per individual customer. When you really look at performance, one of the things about doing this in software that makes it fundamentally different is that when you build queuing systems in ASICs, you've got to think about the functionality and the scale at the same time, because once you've laid down a chip and you put memory cells in it, that's what you've got. You don't get the ability to go and change that later. It's just, you're in the world of building parts. And one of the questions we often get is people say, how big's your TCAM? And so TCAM is a construct inside hardware, which is, the table entries for forwarding. And of course, in our world, it's just a chunk of memory that we allocate. And so our queuing structures can be largely as big as they need to be, with the proviso, of course, that the more things you turn on, the more clock cycles it takes. But we can meet the 10 gig edge requirements with the current generation, in fact, the last generation of Intel forwarding platforms.
Very good. Nice, fully answered question, Adam. So here's another one. Is NFV available to test? If not, what's the timeline to test? And can it provide all the services that a broadband service provider wants to offer?
We have operators today that are testing the solution that we described using both our controller and edge platform and a variety of different virtual routers. There are a variety of virtual routers available in the marketplace, each with different performance optimization techniques associated with them for slightly different use cases. And we can demonstrate and test the virtual router and virtualized edge functionality today.
Cool. So we have some other really interesting questions. I want to make sure we ask the most interesting ones. And by the way, those of you who submitted questions, if we don't get to your question online here, we do have them and we will be able to answer them afterwards directly to you. So here's a good question. What are some of the key requirements for the NID, the virtual CPE? So one is what physical box still sits at the broadband consumer site or business site, and then what happens, what gets virtualized, put in the software?
Yeah, what we're being told is that there's an interest in very simple physical termination devices that have simple layer 2 functionality, perhaps in some cases some limited amount of programmability, but very simple layer 2 edge termination devices that have got, PON on one side, DSL on one side, and Ethernet on the other side of that. And being that they're simple devices, there's less need to cycle these around, and in many cases, the existing terminating device in the premise can be used for that purpose. And then the rest of the componentry, the managed service router, IDS, those other components can be picked up and moved into the cloud infrastructure. And then, I think we think about, the initial path down this of, those being very discrete functions of perhaps a virtual enterprise router. But there are topics where this gets, somewhat more interesting and complicated as people rethink and operators rethink the topology associated with the network. And one of the topics that you and I have spent a little time chatting about is, firewall functionality and how that gets, kind of integrated with this virtualization world. And it logically follows that, that firewall functionality is going on both at the service provider infrastructure VNF and in the service VNF that the customer has. And the difference between them is largely, at a very simple ACL perspective, is very minimal. I mean, it's basically programming steps to a forwarding engine. And so how that gets merged together for the very simple ACL style functionality, perhaps is an area where we'll continue to see innovation. And then that follows on to kind of the next level of higher level, stateful firewall environments.
So a couple of comments from my point of view on this question, and that is, I know Telefonica, I like the way they describe, they have a broadband setup in Brazil, and essentially they think of the actual physical device at the consumer side as a connectivity point, just as Adam was describing. That connectivity point then connects, and it doesn't need much intelligence or programmability, and all of the functions that are served on network. The other observation is Colt in Europe has a bunch of enterprise customers, and some of them have indicated the interest that they want a physical box on their premise with the firewall in it. So that's not a consumer, but on the enterprise side, there's some need for a CPE that does have the ability to run DNS, have a small NFV environment in it, and there the IDS and the firewall can be executed. So those were my comments on this. So Joanne's noting that we're getting up close to the end of time. So Joanne, why don't I turn it over to you? And Adam, thank you. This has been very informative. I always consider it a great webinar if I've learned a lot, and I've learned a lot even more today than when we were practicing. So this is good. So
yeah,
Joanne?
I agree. I agree, Michael. Thanks. And I hate to cut the discussion off. I know we have a few more questions here, but as you noted, any questions we didn't answer, we will be able to follow up with you right after the webinar. So thank you for participating, everyone. Special thank you, of course, to Adam and the Active Broadband Networks team. It was a very good discussion here. I know there's a lot of new technology that's coming out. Virtualization is a question a lot of operators are looking at. So we hope you learned something here. And as Michael mentioned, I know he said he learned something here. So that's always good to hear from an expert in the field. So Thank you to Adam and Active Broadband. Thank you to Michael for this presentation today, and especially thank you to the audience for participating today. We hope you enjoyed this session. We hope you join us for more sessions with the Infinetics IHS webinar program. And this topic, this presentation will be available for you shortly. You can view it again. You can share it with your colleagues. And please join us for future Infinetics IHS events. And again, thank you for your time today. Thanks, everyone. Bye-bye.
Thanks for joining us.
Thank you.
Bye-bye.